Lesson 117 is about direct and inverse variation squared. Now in Lesson 113 we learned what direct variation and inverse variation were. And remember what we were doing, we were comparing two quantities, and in direct variation, when things vary directly, that means they both change in the same direction, and we write that as a fraction, and that ratio stays constant. Inverse variation, one thing is increasing and the other is decreasing, or vice versa, and we write those two quantities as factors of each other, and that product stays constant. Now the same thing's going to apply here. We still write direct variations as a ratio, inverse variations as factors of each other, except one or the other of those relationships will be squared. So that's the only difference here. Now these direct and inverse variations, there are lots of applications in our physical world where there are direct and inverse variations or relationships between a pair of quantities. And it's interesting that a lot of the design that God has put into our physical world, it can be explained with simple mathematical relationships. For example, in this problem here, this is a real relationship. The force of the wind on the sail varied directly with the square of the wind's speed. That is true. There is a relationship of the force to the square of the wind's speed. Initially, the force was 20 pounds when the speed was 10 miles per hour. What is the force on the sail when the wind speed doubles? So let's just think about this. It says the force of the wind on the sail varied directly with the square of the wind's speed. So it's a varies directly relationship, so we'll write that as a ratio. Let's just do F for force over the wind's speed. I'll just call that W for wind speed, and we'll say squared on that because it's the square of the wind speed. And so we could have an initial force and wind speed and a final force and wind speed. The ratio is constant though, and so that's why we can set those two ratios equal to each other. Now it says that initially the force was 20 pounds on that sail when the speed was 10 miles per hour. So we can go ahead and substitute that in for our initial values. The force was 20, so that's 20 over 10 squared, so that would be 100. And so set that equal to, what is the force? We're trying to find F2, so we don't know that. When the wind speed doubles. So if the wind speed doubles, that means it'll go up to 20 miles per hour. 20 squared, we need to make sure and square it. That would be 400. Now, I'm not sure why it took it so long to put that F2 up there, but it finally came up, and now we can put the 400 underneath it. Now we can cross multiply to solve for F2, or whenever the variable is in the numerator, it's easier just to multiply both sides by that denominator of 400. So the 400s will cancel there on the right. On the left, we'll end up with 4 over 1. And so we can just do 4 times 20 is 80. And so our final force, I'll write it over here to the left. I'll just say F2 equals 80 pounds. So see what happened there? When our wind speed doubled, our force did not double. It quadrupled, basically. It increased by a factor of 4. So these problems, if there's a squared part in there, you set them up just like you do other direct and inverse variation problems, except one or the other of the quantities will be squared, and you just need to make sure and do that. Okay, well that's all for lesson 117.